Welcome back. In the previous video, I explained that increasing the number of classifiers in the Ensemble classifier yields or increases the accuracy of the Ensemble classifier, of course. But this was under the assumption that all classifiers are independent. That is, we can think about a situation where the classifiers are not independent. Say, for example, that I trained 100 decision trees. Say that this is the first decision tree, this is the second decision tree, and I have 100 decision trees. Say that I trained them with the same algorithm, and also I trained them with the same training dataset. So what does that mean? It means that if this decision tree here, the first decision tree, gives me an error, then all of these decision trees would also give me an error because they are similar, they are the same classifiers, and they are trained with the same algorithm and on the same training dataset. This means that if this one makes an error, then all other classifiers would make an error, and in this case I don't have any advantage in terms of accuracy. Therefore, and the reason of course is because all of these decision trees or all of these classifiers are dependent. Therefore, one way to reduce or to get this accuracy is by reducing the dependency of these classifiers, reduce the dependency of classifiers between each other. And this is what I want to talk about in this video. This is an introduction about dependency reduction. Now, I will talk a little bit about in general about the methods that are used, or the main methods that are used for dependency reduction. One way to reduce this dependency is by using different training algorithms. Another way is by using different classifiers or predictors. For example, I can use SVM, decision tree, nearest neighbor, etc. I can use different classifiers. And another way is by using a different training dataset. And this is what I want to talk about in this video. I will talk about how to reduce the dependency between classifiers using different training dataset. Well, the most obvious and straightforward way to reduce this dependency is by collecting a different training dataset for each classifier. For example, if I have 100 classifier, I need 100 training dataset. Similarly, if I have 1000 classifier in my Ensemble classifier, I would need 1000 training dataset, and this is really not something that is practical, and this is not easy. This is a daunting task to collect 100 training dataset. Therefore, we can think about another way to create a new training dataset by using the original dataset. So what we can do is to collect only one training dataset. For example, say that I have this following dataset that is composed of 4 features. So I have here 4 features, and say that, for example, I collected 10 samples or 10 instances on these features. It's just an example, of course. This is a small data set, but I'm using this just for the sake of the example. So what I can do is that I can generate a new data set by using this data set only, the original data set. And there are 2 ways to do that. The first way is called random batches. So what I do in random patches, also I have 2 methods. Now, what is random patches? In random patches, what we do is that we resample these samples that we have here, or these training instances. And the first way to resample these instances is by taking in a random way a subset of these instances. For example, say that for a given training data set, say that the first training data set I will generate is composed of the first, second, and third sample, and the training or the second training data set that I would generate is composed of the third, fourth, and the first data set, or the first sample. And again, on the third training data set, I could take, for example, the seventh, the fourth, and the second training instance, and I can keep going until I create a data set for all my classifiers. And what you should notice here is that for each training data set, I'm not replicating the samples. For example, here I have one is repeated only one time, the second sample or the second training sample is repeated only one time, and the same thing is true on the third sample. And the same thing is true here, same thing is true here. That is, I should not, for example, for a given training data set, say for example the fourth training data set, I should not take 7, 7, and 2. So this is not allowed, and for, of course, in this case only, right? Because I'm just taking a limited number of instances or training instances, and I don't replicate them. And when I don't replicate the instances, what I'm talking about is the pasting method. So the Ensemble classifier that is trained with this type of training data set is called the pasting method. So this is a training data set without replication, and the method in that case, or the Ensemble classifier in that case, the Ensemble classifier is called the pasting method. Now the first inconvenience we can notice here is that the number of training instances is smaller than the original data set. Here we have 10 samples, but here we have only 3 samples. Well, another way to generate the training data set based on the original data set is the same way as this one. We can just take random samples, but I'm allowed to replicate my samples. For example, if I want to take 10 samples for each training data set, I can replicate samples in that case. I can, for example, take here 1, 2, 3, and I can replicate 3, I can replicate 1, I can replicate again 2, I can take, for example, 7, 8, 9, and 1. Right? So this is an example of a resampling, or an example of generating a new dataset with replications. In this case, it was without replication, but here I'm talking about resampling or creating a new training dataset with replication. So this is with replication, and this dataset here, this dataset that is generated with the process of taking random instances or random training instances from the original dataset with replication is called bootstrapped data. So this is a bootstrapped dataset. And when we have an Ensemble classifier that is trained with the bootstrapped dataset, then we are talking about the bagging method. When we have an Ensemble classifier that is trained with a training dataset with replication, which is the bootstrap dataset, I'm talking about the bagging method. Now, what I did here in general is just taken in a random way samples from the original data set. Now, another way to generate the new training data set from the original data set is called random subspaces. So here, this type of data set is called random patches. I can also create a new data set with something called random subspaces. And what does that mean is that instead of taking just samples from this original dataset, I can take instead features or a subset of features from the original dataset. For example, I can say the first training dataset is composed only of F1 and F2, and I'm allowed of course to take all the samples or all the training instances. And I can say again the second training dataset can be composed of F2 and F3, and I can take, for example, F3 and F4, or F4 and F2, and so on. I can keep going. The idea is to sample the features, that is, just take a given subset of the features. And the reason and the situation when this comes useful is when we have a large number of features. For example, here we have only 4 features, but this method of sampling the features becomes more interesting when we have a large number of features. For example, an image where each pixel is considered as a feature. Say that we have an image, for example, that is composed of 500 by 500. This is the number of the total features that we have if we take each pixel as a feature. So in that case, we can do this feature sample, and it becomes more interesting when we have a large number of features. Now, if you notice here, I took only a subset of features that contain 2 features, right? 2 features, all my subsets contain 2 features. But what is the optimum number of features that we can take in a given subset? Well, this is of course is done by a process of trial and error. Again, we can know for sure. This depends upon your application. Therefore, what we can do is just to test different number of features, and then see what is the accuracy of our model, and then we take just the number of features that yielded the highest accuracy for our Ensemble classifier.